Say you have been feeling under the weather for some time and you decide to go to the doctor as your regular checkup. When you get there, the doctor tells you that you have a disease and it is known to be deadly. So you ask yourself this question: will I be alive within the next 5 years? That's where I come in to possibly answer that question. So to do that, I will need your previous medical records and some additional information from you. So for this context, let us define a model as a system that takes in collected data and then make predictions about the real world. In biostatistics, basically statistics applied in biology, there's this iconic model called the CoE-MaSS model. The CoE-MaSS model predicts the relationship between a characteristics of an individual as well as your health outcome. By characteristics, it could be age, gender, your previous medical records, and your outcome being alive or not. So to estimate this relationship, we will need a function. And for this context, let's say a function will be something that takes in data as input and spits out an output which is relative to your initial data. So a function that will help me estimate this relationship will be called a partial likelihood function. So a partial likelihood function takes input as your characteristics, being age, gender, previous medical records, and it spits out the relationship between your characteristics and your outcome. So I want this relationship in order for me to tell you whether you'll be alive in 5 years' time or not. So in previous literature, huge data sets were placed in this likelihood function, and that made the computation time quite long. So to remedy this, I aim to reduce the data set for the likelihood function to increase the computational time while maintaining the quality of that relationship. And if successful, I will be able to tell you that in 5 years, you will be alive or not in a much quicker time frame. Thank you.